Hi, this is Robert Go for IOSEA, the technology company specializing in indoor direction finding and real-time location using BLE 5.1. Today, I want to share with you our recent installation at a car repair shop in Costa Mesa, California. Here we installed 3 IOSEA locators within the rafters of our structure to demonstrate IOSEA's antenna technology and real-time location service. We've intentionally chosen the garage setting for our demo because it's hostile RF environment, susceptible to RF signal reflection and interference, or multipath as we call it. In addition to the many cars within, there are car lifts, tools, equipment throughout that add to RF complexity. Just below our locators hang a series of fluorescent lights with metal housing that serve as physical obstacle and add to reflection and electromagnetic interference. Adjacent to the concrete structure is an alleyway with several parked cars. For this demo, we are using 3 IOSEA Signal Gen 2 demo kit locators. Each locator consists of a sub 6-inch diameter, 12-element antenna array, uses Nordic Semiconductor's BLE 5.1 NRF 52833, and a Raspberry Pi 4. The Raspberry Pi hosts and processes IOSEA's signal angle of arrival algorithm, then serves angular data to the cloud, for which it is processed in real time and shared via an iPhone app. Our video demonstrates 2 screens simultaneously, one screen showing a video of myself with the tag, and the other screen a topographical representation of the garage. The red dot in this graphic represents the tag as it is monitored using our locator system while it is carted throughout the premises. Here's a closer look at the tag that we're using, which is Nordic's EV kit using their BLE 5.1 NRF 52833. For the sake of simulation, we're putting it within a shoebox and carting it within a metal cart. Notice that as I move the cart, the locators track the tag and the red dot in the graphic moves as I roll the cart exiting the garage. As I exit, note the non-line of sight condition, yet the red dot continues to track the location accurately. As I turn into the narrow alleyway, this serves as a difficult and hostile RF environment due to reflection between the walls and parked cars. Despite this, the location is accurately maintained throughout the graphic. Turning the corner, we re-enter the rear entrance of the garage and navigate through a narrow pathway between cars, returning to the original position, all while the location is accurately represented in the topographical map using IOSEA's locator system. The purpose of this video is to demonstrate IOSEA's antenna technology, software algorithms of direction finding, and real-time location in an RF hostile environment. If you seek to incorporate such technology within your own device or solution, please feel free to email me, rgo@iosea.net. Thank you for your attention.